Hey, what's up everybody? My name is TJ.
I'm Jeremy.
I'm Dillon.
And I'm Min.
And Anthony is behind the camera doing most of the camera work today.
And today we're going to be doing 3 experiments to show the effects of gravity.
For our first experiment today, we are going to be talking about gravitational potential energy. As the height of this marble from the ground increases, then this potential energy will increase as well. We're going to be going from 0.5 meters to 1 meter, and this shows how much energy it has. The potential energy will be converted to kinetic energy, and this will be shown in the indentation that the marble makes into the sand. This is a very informal experiment, but it just shows how much the kinetic energy will change. The equation for potential energy, gravitational potential energy, is potential energy equals mass times gravity times height. The height, as I've mentioned earlier, will vary. We will have one with 50 centimeters, which is 0.5 meters, and 100 centimeters, which is 1 meter. The mass has already been pre-measured at 6 grams, which is 0.006 kilograms. Gravity, which is universal and constant, is approximately 9.81 meters per second squared. Again, the equation is potential energy equals mass times gravity times height. Okay, so this will be how our procedure works. I will be holding my marble from 50 centimeters and 100 centimeters from the ground. Both of these positions will have maximum potential energy at its certified point. So at 50 centimeters, I will drop it, and at 100 centimeters, I will drop it. At these points, it will have potential energy, and the potential energy will convert to kinetic energy as it falls to the ground, or the sand, as a matter of fact. So whenever it gets to the highest point and it falls, the potential energy will be converted to kinetic energy. And its very minimal point before it hits the sand, it will have very high kinetic energy. Not the utmost max, but very high kinetic energy. So when it falls, it will make a crater into the sand. At 50 centimeters, the crater should be pretty big, but at 100 centimeters, the crater should be bigger than the 50 centimeters. This shows that gravity is acceleration as well. As a result, potential energy is converted to kinetic energy, and although it is somewhat informal, it still shows that potential energy is being converted to kinetic energy, which thus creates a bigger crater. Thank you. Okay, so for this experiment, I'm going to have Min over here help me. He's going to be holding the meter stick, or the meter rule, or whatever you want to call this thing, and he will be showing how far it is above the ground. So right here, he currently has it at 50 centimeters, which is 0.5 meters, and I'm going to drop it and hopefully not miss. Alright, so the marble is right here at its very high gravitational potential energy, and bam. Alright, so now the crater has already been made with the 50 centimeters, and now we're going to do 1 meter, which is 100 centimeters. So go ahead and get the 1 meter ready. And carefully take this from there. So the indentation has been made, and we're going to compare it after we do the 100 centimeters, so hopefully I don't miss. That's 100 centimeters?
That's all on you, man.
Oh Lord. Oh Lord, okay. Yes! Okay, so now we have both of our craters here. The one to your right is the one for the 50 centimeters, and the one to your left is the 100 centimeters. As you can tell, if you can tell, the crater is much larger to the one to the left. The 100 centimeters, the greater potential energy to kinetic energy. I'm going to stick my finger in here. And there. And as you can tell, it's much, much deeper. The gravitational potential energy in the very top converts to a higher kinetic energy all the way to the bottom. Although not all, it's the maximum, or at least almost the maximum kinetic energy will be reached whenever the potential energy is being converted to the bottom. So right before it hits, the maximum kinetic energy will be reached. So right here, left, you can tell it's very deep, and right, it's not very deep at all. You can tell at all. Thank you. Okay, so from our experiment earlier, here are the equations. Potential energy is equal to mass times gravity times height. Kinetic energy is equal to 1/2 mass times velocity squared. Now, as potential energy is at its greatest point and kinetic energy is being converted at the bottom, The equation is as follows. Mass times gravity times height is equal to 1/2 mass times velocity squared. Mass will cancel out, and so the resulting equation is gravity times height is equal to 1/2 velocity squared. This can be used to convert the potential energy at the highest point to what the kinetic energy will be at the bottom point. Okay, so we have our equation here. Gravity times height is equal to 1/2 velocity squared. So, how does this whole experiment relate to gravity? Well, gravity is acceleration, and acceleration is the change of velocity per second. So 9.81 per second squared. That means that every second, the velocity will increase by 9.81 meters per second. So at 1 second, it'll be 9.81 meters per second. Then the second, it'll be added 9.81, which is about 19.62 seconds. What that means is that at a higher point, at a higher height, it'll take longer for it to fall. As a result, the acceleration at the bottom will be much greater than the acceleration at the top. So 9.81 around here and much higher down here. Now this is the whole point of potential energy, gravitational potential energy. As you can tell from our experiment above, 100 centimeters was the highest point that we had, and whenever we dropped it, the crater was very big, and at 50 centimeters, the crater was not as big. As a result, you can tell that 9.81 was being, the velocity was constantly being increased. So 9.81, 9.81, 9.81 until it reached the crater. And at the very top, the marble had more time due to the acceleration, the marble had more time to increase its velocity. As a result, the velocity is increasing. It has more time to increase its velocity due to the greater height, and as a result, that is the greater crater. So, gravity times height equals 1/2 v squared, and that is the conversion of potential energy to kinetic energy.
Our second experiment involves a little projectile motion. What we're going to do is, we're going to shoot the bullet this way and drop a bullet from the same height. And what's going to happen is, they're going to touch the ground at the exact same time. Jeremy, yeah! Alright, for the first part of our second experiment, we needed to find the time that this bullet takes to reach the ground. So the height that we're using is 1 meter high, and we're going to be using this height for the rest of our second experiment. So Dillon here, he's going to drop the bullet, and he's going to time it. So you got 0.44 seconds. For the second part of this experiment, I'm going to shoot the bullet horizontally. And it will take the exact same amount of time it takes to reach the ground as if you drop the bullet. And what happens is you have to have the gun exactly horizontal. If you angle it in any way, that will change the amount of time it takes for the bullet to reach the ground. So Min over there has meter sticks up and 1 meter. I'm gonna go over there and shoot it. Dillon's gonna time on 3. Alright, ready, Dillon? 1, 2, 3.
So the time is 0.47 seconds.
This is the projectile motion equation that we use for this experiment. Its height equals horizontal acceleration times time plus the vertical acceleration times time squared. Now, because there wasn't any force acting on the bullet before it was shot, this becomes 0. And then if you solve for time, then you'll end up getting time equals square root of height divided by the vertical acceleration. Then you plug the variables in. We use the height of 1 meter, and our vertical acceleration is 9.81 meters per second squared. After you solve for t, you end up getting 0.45 seconds. The time will then equal to 0.45 seconds. That's more or less close to experimental values of 0.44 seconds and 0.47 seconds. This is the drop, and this is shooting it horizontally. So our results may have been a little bit off due to human error, but it's more or less the time that it generally takes for the bullet to reach the ground is the same. Now, third and last experiment, we put Dillon on a scale in an elevator and made him ride up and down. We took his actual weight.
So now I'm going to measure my actual weight.
And it got 109.2 pounds. So as the elevator go up, so does the force applied, and that goes against gravity.
Where are we going, Dillon?
Hold up.
Oh, okay.
Going up?
We're going up.
We're going up. Yay!
Just someone farted.
Shit.
which causes the weight to go up to 110.6 pounds. The opposite would happen if he were to ride the elevator down, because the force is now going alongside gravity, which would cause the weight to go down. So weight increases when the elevator goes up and vice versa.
So the weight shown on the scale is dependent on the acceleration of the person standing on it, which in this case is Dillon.
1, go.
This video concludes the experiments of the effects of gravity. Did I say that right?